This has to go through to both. So x plus 1 is y. And now Grant did the derivative of that using the quotient rule from last class. Right? Let's do it. Quotient rule says you take the derivative of the top. What's the derivative of the top? Well, let me do it. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Right? And derivative of x is 1, and 1 times that is x plus 1. And then over here, what's the derivative of x plus 1? 1, and then times x. So x and then minus. So minus x, and then all over our common, or all, not common denominator, all over this denominator. And do you see, you get that, and you get the same answer. And that's one of the beautiful things about math, is as long as you don't mess up, right, as long as you don't break a rule, then you should all get the same answer no matter how you do it, right? I think if we would have stopped here, right, if we would have stopped here as our final answer, and then looked in the back of the book and saw this, right, we'd be a little bit like, whoa, how is that? I must be wrong, right? No, there's just algebra that takes you there, right? That's why I've urged, and I'll urge again, that as you're doing your homework for these problems for product rule, quotient rule, chain rule, that you try and make your answer look like the back of the book, because all that little algebra is actually a good thing. I'll tell y'all a quick story. Well, I don't know if it's going to be quick, but when I was in graduate school, one of the things that I did in grad school is I worked for the university, and I was a teaching assistant. So what that meant is that I had two jobs in grad school. I was a tutor in the math tutoring lab, and then I also did what were called calculus recitations, which meant on Fridays the professor would teach the calculus class, but on Fridays the class would come and meet with me for an hour, 15 minutes, and just ask questions, right? Ask questions. So I would have to answer questions and do problems. It was just basically me doing problems for an hour. And I had this one class where we did a problem, and I got the answer, and I kind of simplified it, but not completely. And then, went on with my day. Well, like the next day, a student that was in that recitation came into the tutoring lab all pissed off and was like, interrupted me while I was helping a student, was like, you need to go and apologize to the class and let the professor know that you messed up and you made a mistake. You gave us this answer, and here's the answer in the back of the book, and they're not the same. And I said, oh, shit. They just don't know how to do the algebra, right? So I had to sit him down and show him how to get from my answer to the back of the book answer and show him that it was just algebra, right? So the moral of the story is, in a calculus class like this, I want to teach you the calculus, right? The algebra you're going to have to work on your own. You're going to have to work on that algebra, all right? So work on getting your answer to look like the back of the book. I think we're ready to turn the screws a little bit, yes? Everything I've given you up to this point has been just chain rule, right? Chain, chain, chain. But last class we learned product and quotient. So I wonder if you can somehow put these together and have a problem that involves more than one of these rules. Something like this.
Is this still 2.5?
Yep, we're in 2.5 all day. So now you have to recognize that you do have composition, right? You have a function inside of another function, right? The inside function is all of that, right? That's your inner function, and here's your outer function. So I can start with my chain rule, right? My chain rule says I start with the outer function. So what's the derivative of the outer function? Cosine. Cosine of what? All of that, right? Don't touch it, right? Leave it alone. But then times what? The derivative of what's inside. But that's going to require quotient rule, right? This is a quotient. So I'm going to write over here x to the third plus 1 over x to the fourth plus 1. And because I don't know what that answer is just off the top of my head, I'm going to put derivative, right? Do y'all see the chain rule here? It's derivative of the outer function evaluated at the inner function times the derivative of the inner function. Now, to do that, I'm going to go over here on the side, and I'm going to do some scratch work. Okay? I'm actually going to do that derivative over here, and then when I get that answer, I'm going to go stick it back over there. So if I try and take the derivative of x cubed plus 1 over x to the fourth plus 1, using the quotient rule that we learned last class and that you all are experts with now, it's the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared, right? So let me write that out. So if you're doing quotient rule, can we all agree that the bottom is going to be this? Like that doesn't require any work. It's just whatever the bottom was here squared, right? All right. Top left corner is the derivative of the top. What's the derivative of the top? 3x squared. Times x to the fourth plus 1. Minus, now, the derivative of the bottom. 4x cubed times x cubed plus 1. And then all over the bottom squared. That is the quotient rule, isn't it? Now, last class I just left this alone, didn't I? But I'm going to clean this up a little bit. I'm going to distribute here, I'm going to distribute here. And when I say distribute on the second one, I'm going to distribute that negative as well. So I will have 3x to the sixth plus 3x squared minus 4x to the sixth or ninth. What is that? What do I do? Add, subtract, multiply? Add them, sixth. And then minus 4x cubed. And then all of that over x to the fourth plus 1 squared. Combine like terms?
The 3x to 6.
Yeah, these, I'm left with minus one of them, right? So negative x to the sixth, I'm putting it in descending order, minus 4x cubed plus 3x squared all over my common denominator, like that. Question? You sure? I'm going to be trying to show a little bit less in terms of this setup on these, just because we have to kind of leave some of this stuff behind, or else one problem will take us an hour if I show every little thing. Y'all okay with that derivative? Any questions? Okay, so here we go. We have cosine x cubed plus 1 over x to the fourth plus 1 times that. Negative x to the sixth minus 4x to the third plus 3x squared all over x to the fourth plus 1, that quantity squared. And that's it. I mean, that is the derivative. So if we go back and take a look at this, what we had was a chain rule, right? This was a chain rule, but while we were doing the chain rule, we had to do a quotient, right? Say it again. We had a chain rule, and while we were doing the chain rule, we had to do a quotient rule. I'm now going to give you an example that's the opposite of this. It's going to be a quotient rule, and while we're doing the quotient rule, we're going to have to do the chain rule. It's just a slight, change of things. So I'm going to set you up with a quotient and force you to do a chain while you're doing the quotient. So how about I give you keep it nice, I guess. Let's do sine x squared plus 1 over x to the 4th plus 1. So when you look at that, and this is the part that's hard to teach, what do you see? Do you see product? Do you see quotient? Do you see chain? What do you see? Does everybody see quotient first? Quotient, right? Quotient. Now, when you look, quotient rule says that you're going to need to do the derivative of the top times the bottom minus derivative of the bottom times the top, right? So let's just do that. Let's write that formula out. According to this quotient rule, I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. That's just the quotient rule, right? Now, in the middle of this quotient rule, right in the middle of this, I have two derivatives I have to take, right? This one is super clean. Would you all agree? That's just 4x cubed. But this one is a chain rule, right? You have composition there. It's sine of x squared plus 1. So I'm going to need to make sure I know that derivative. So why don't I do some scratch work again here on the side for the part that I think is the harder part of that. So if I take sine of x squared plus 1 and I take its derivative, then the outer function here is sine, so derivative of sine is cosine of the inside. And then times chain rule, derivative of the inside, which is just 2x. And if I clean that up, I get 2x cosine x squared plus 1. Yeah, and that's just what this top left corner becomes, right? So continuing over here, I have that this right here, right, is going to be replaced with that. So 2x cosine of x squared plus 1. And then I still had next to it x to the 4th plus 1. And then minus, I need to take derivative of that, which we said was easy, 4x cubed. Then times sine of x squared plus 1. And then all of this divided by x to the 4th plus 1 squared. How do you think you get to a point where you're comfortable with all this? Practice. You've got to do a lot of problems to get to a point where you can sit down and say, you know what, really doesn't matter what I'm given, I know how to apply the rules. That's going to be my final answer. I'm just going to leave it like that. How about this one? Fifth root of x squared secant x. What do you see? What do you see? You see composition? You see something inside of something else? What's the thing that you see inside?
X squared.
X squared secant x, right? That's the inner, and the outer would be the fifth root, right? But your inner is actually a product, isn't it? The inner is actually a product. So when we do the derivative of the inner, we're going to have to do a product rule. So I think, again, a good way to start this problem is to first rewrite it like this. 1/5 power. Isn't that the same thing? Yes?
So secant x is not a composition here.
No, it's not. It's just secant of x, right? Now, if there was something other than x in here, then that would have a composition as well. All right. Do you want to try this one? Are you okay rewriting it like this?
Yep.
Okay. So the outer function is the 1/5 power. So how do we deal with that?
So the 1/5
1/5 out,
and then 1/5 minus 1 would be negative
4/5, good. Now what goes in here?
x squared secant of x.
Right, and don't touch it, right? Everyone good there? That's the beginning. Now times. Now you have to take derivative of what's in here, right? And maybe you need to go to the side and do that. I don't know. I mean, everyone's going to be different here in this class. So if I ask you to take derivative of this, there's your product, right? The product rule said derivative of the first one times the second plus derivative of the second times the first, right? So derivative of the first one, 2x times the second plus derivative of the second one. Okay, that one's not one that a lot of people know off the top of their head at this point in the class, but you can look it up, right? What's the derivative of secant x? Secant x times tangent x. So secant x times tangent x, that's derivative of the second one. And don't forget, you have to multiply by the first one, x squared.
You'd be able to just put that in front, right?
Do what?
Take the x squared.
Yeah, I'm going to actually put the x squared in front of that. All I did there was move the x squared out in front of this, because I just prefer to have them like that. That's the derivative of the inside, isn't it? And that gets tacked on to the end of this. In parentheses, because there's two terms. 2 secant x plus x squared secant x tangent x. There we go. Here's another one for you. Students make mistake on this. Students make mistakes on this one. Secant of x squared plus cosine x. What are y'all seeing? Composition? Okay, if you see composition, what's the inside function?
X squared plus cosine.
X squared plus cosine x, and then the outer function?
Secant.
Secant, right? All right, let me see. I'm going to go to my roster, call somebody here. Enrique? Right, how's it going, Enrique? Good? All right, so Enrique, the outer function is secant, right? So what's derivative of secant? Secant x tan x, right? See, this is the part that most students have trouble with. What do I write? Secant of the whole inside, tangent of the whole inside. So this goes back again to like, what's derivative of secant of my hand? It's secant of my hand, tangent of my hand. So I need to write secant of x squared plus cosine x, tangent of x squared plus cosine x. You see? A lot of students will write, on that part, they'll write secant x, tangent x. They won't write secant of the inside, tangent of the inside. All right. Enrique, you want to keep going? Okay. 2x 2x minus sine x. Good. So that's just tacking on the derivative of what's inside. And I need parentheses because there's more than one term, right?
And then could we have taken the 2x minus 5?
2x.
I mean 2x, the negative, and then put negative 2x.
This is all together, so you can't, you could put all this out in front, but you can't just pull the 2x. All right. Now, believe it or not, this one rule opens up, this opens up the world to us in terms of what we can take the derivative of. The only thing we haven't really discussed yet in terms of derivatives are the exponential and logarithmic functions. Like what's derivative of like e to the x or natural log or something like that. That's going to come. But right now, you now have the rules from Cal 1. That's it. There's no more to it. It's power rule, product rule, quotient rule, chain rule. Once you have those, that's it. And now you just learn how to use them. The big challenge is in Cal 2 when you have to go backwards. So in Cal 2, we start here and end here. We start here, end here. And it's much harder to undo this stuff than it is to do it, all right? So I always say, if you need to do Cal 2, your success in Cal 2 is dependent upon how well you understand chain rule and product rule and quotient rule in Cal 1. If you don't ever understand this, then it's going to be really hard to go backwards. All right, here's some that seem trivial, but they're worth us talking about. Let's do, how about something we haven't done? How about cotangent of 5x? What do you see there? That is composition, right? It's something being plugged into something else. The inside is 5x, the outside is cotangent. So you go and you say, all right, the outer function's cotangent. What is the derivative of cotangent of something? So you look on your formula sheet. What is it? Negative cosecant squared of what? X on the formula, right? But for us, it's what? 5x. Right? What's the derivative of cotangent in my hand? It's negative cosecant squared in my hand. Times, don't forget this part, times what? 5, right? Where's that 5 coming from? The derivative of 5x. How do you take derivative of 5x? Well, you just bring the 5 down, right? And then what's derivative of x? 1, right? Don't do product rule on this, right? Don't do product rules. Some people will do product rule on that. If you do it, it will work, but it's a waste of time. Constants always come for the ride. All right. Really, we're at a point where you need to practice. You need to practice. Let me see. What time we got here? It's probably a good break time. What are y'all thinking?
Yes.
Hold on. Let me look at something real quick before we're going to get out of here early already. Don't worry. Not yet. No. All right, let's do one more problem. Let's do one more problem before we, whoa. Find equation of tangent line to y equals, let's do x over the square root of x squared plus 3 at the point 1, 1/2. All right. There's a few ways to do this. It really kind of depends on how you want to go about it. But there's no way around the fact that you're probably going to need to use some chain rules. So why don't y'all work together on this, see what you can do, and I'll give you a few minutes. Let's take 10 minutes on this, 9 minutes. See if you can get an equation in 9 minutes. And then we'll take our break.
First, we use the quotient.
I'm going to start working it out on the board, but I'm just going to do it silently.
No, it's a negative taking it to the derivative of the square root. What? And then you have entering the boundary fact, and you're trying to take the derivative.
Yep.
Why is square root 4 on the bottom?
Oh, I didn't. That's my mistake. I don't know why I did that. I was just working fast. That's a 4. 4, 4, 4, 4, 4, 6, 3, 4, 6.